In our today's discussion, I am going to discuss in a simple random sampling how the sample of a specific size is drawn when sampling is done with replacement and without replacement. But before starting, let me revise some of the basic terminologies which we have discussed in our previous lectures. And starting from very basics, like you are very much familiar with what is statistical population, what is a sample, and what are the advantages of working with samples instead of population, and how we do sampling, and sampling, which is the procedure of drawing samples from the population. And further, what are the types of sampling, like probability sampling, non-probability sampling. In probability sampling, we have discussed simple random sampling, stratified random sampling, cluster sampling, and systematic random sampling. But as I have already told, that for numerical questions point of view, we will only be working with simple random sampling. And also, particularly in simple random sampling, we will be working with the sample of size 2 only. When the sample of size 2 will be drawn from the population, when sampling is done with replacement and sampling will be done without replacement. Okay, now let's start with sampling with replacement. What is sampling with replacement? In a simple random sampling, a sampling unit is replaced into the population before drawing the next sampling unit. It is a sampling technique in which if I select a sample to be included, a sampling unit from the population to be included into my sample, I am saying that that unit will not be returned back into the population before selecting the next unit from the population for my sample, for my next sample, right? And sampling without replacement, it is alternative of simple sampling with replacement. In simple random sampling, a sampling unit is not returned back into the population before drawing the next sampling unit. If I have selected a unit to be included in the sample, it will not be returned back into the population before selecting the next sampling unit. And remember, in case of sampling with replacement, the population size remains the same at every successive drawing of the sampling unit. But in sampling without replacement, the population size is being reduced at every successive drawing because the population unit is not returned back into the population before selecting or before drawing the next sampling unit. Right. For a numerical question point of view, I have taken a problem for you from a book, and we will be doing all the work, all the procedure on by using the software SPSS. And before starting the procedure on SPSS, let me read the example first for you, the statement of the example for you. It says, suppose a professor gave an 8-point quiz to a small class of 4 students. The results of the quiz were 2, 4, 6, 8. And for the sake of discussion, assume that the 4 students constitute the population. He is saying that the results of these 4 students are my population. 2, 4, 6, 8 is my population. And look, the size of the population here is 4 as it constitutes 4 units. Draw all possible samples of size 2. It is mentioned here that we will draw the sample of size 2 with replacement and secondly without replacement. I will be doing both of these cases for you. Form the sampling distribution of sample mean x bar. Also prove that mu of x bar is equals to mu. What we need to do is, by using this population, we will form the samples, all possible samples of size 2 by using these two techniques, and then we will form the sampling distribution of the mean. The sample statistic we calculate here is sample mean. We will calculate the sampling distribution for sample mean, and then we will prove this expression. And by proving this expression, I mean that I will calculate the answer of this left hand side, that is mu of x bar. I will find the mean of the sample means, sampling distribution of x bar, the mean of the sampling distribution of x bar, and then the population mean. The right hand side I will calculate mu. Mu is the population mean. Okay, this is the first case, the sampling with replacement. And what I have done is I have written the whole population here. Population is 2468. The population size, that is capital N, represented by capital N, is 4, and sample size small n is 2. Total number of possible samples in case of sampling with replacement, the formula for calculating the total number of possible samples is capital N raised to power small n, that is population size raised to power sample size. 4 raised to power 2, 4 square, that is equal to 16. So I must have 16 total samples here. These are the 16 samples, and I will get you learn how I have formed all of these samples. Okay, let's take this first sample. How I have made this, I have chosen 2 from the population. At 2 is chosen at the first stage, at first draw. Then again, as it is the sampling with replacement, so 2 is returned back into the population before selecting the next unit. So 2 can come or can be selected once again. So 2 can come with 2. Similarly, 2 can come with 4, 2 can come with 6, and 2 can also be selected with 8. 2, 2, 2, 4, 2, 6, and 2, 8. Now it's a turn of 4. 4 can come with 2 because 2 is already here in the population, because I have returned it back into the population before it's the turn of 4. So 2 can come with 4 can come with 2, 4 can come with 4, and 4 6, and then 4 8. All of this. Then 6 can be selected with 2, the same lines. 6 can be selected with 4, 6 6, 6 8. Similarly 8 2, 8 4, 8 6, and 8 8. And all of these are 16 total samples. Further, what I have need to do is I need to calculate the mean of all of these individual samples, and I will calculate the mean, that is the X bar on SPSS. What I need to do is I will enter the data for sample 1 and data for sample 2, and by using the compute variable command I will calculate the mean of all the individual samples. Then after calculating the mean, I will find the frequency distribution of this mean column by using the SPSS. And after making the frequency distribution, I also need to calculate the mean of this X bar column, and I also need the mu, that is population mean. I will enter the data of the population into a separate variable, and I will get the mean calculated from the SPSS for this right hand side. And after that, at the end, I need to make a sampling distribution of X bar by using this frequency distribution of X bar. We will discuss it later on. First I will enter the data for both of these samples. I will get the mean calculated, and I will get the frequency distribution and means of both of these sides to be calculated from SPSS. Let me start the SPSS window for you. I will create 2 variables named as sample 1, and I can name sample 2 the other variable. I will enter the data for both the samples, and I can show you here the data for sample 1. This first column is my sample 1 data, that is 2 2 2 2 4 4 4 4, and similarly this column, this first column is my data for sample 1, and similarly in the second column is the data for sample 2. 2 4 6 8 2 4 6 8 and 8. I have entered the data for both of the samples. Now I will calculate the mean. On this third column I will calculate the mean by using these two samples. I will go to transform compute variable and I will put the name as x bar. In numeric expression, you know the formula for calculating the mean of two numbers. How we calculate the mean of two numbers? You are very much familiar with this. Sample 1 plus sample 2 divided by 2. And by using this numeric expression, it will create a variable named x bar which will provide the means of all the individual samples. Here you go. These are the means of all of these 16 samples. What I need here, I need the mean of this column that will represents the mu of x bar. Mean of this column will represents the mu of x bar, this left hand side of the expression. For the right hand side, to calculate the population mean, what I need to do is I need to enter the population data. I can name the variable as x for population and I will enter the data for population to calculate mu, the population mean. My population data is 2 4 6 8. I will get the means for both of these two variables to be calculated. I will go to analyze, descriptive statistics, frequencies, and I will move x bar and x at the same time, and I click on the statistics and then check the box for mean. This will give me the mean for x bar as well as the mean for population, that is x. I will click on the continue. You can also see here the display frequency tables is already checked here. It will also give me the frequency distribution of x bar as well as the frequency distribution of x. Click on OK and it will produce the results. Look here in statistics table, it is showing me the total numbers in x bar columns were 16 and the total numbers in the population column were 4. Mean of x bar is 5 and mean of x, that is population mean, is also 5, which I have written here. The mean of the x bar is 5 and the mean of the population is also 5. So this expression is also already proved. Now I need to make the frequency distribution of x bar, and by using this frequency distribution I will need to find the sampling distribution of x bar. This x bar of frequency distribution has been given in the output. This is the frequency table of x bar. You will take this column. These are the values of x bar which are written only once, which were being repeated multiple times against each sample. So it has written all these values. This is the x bar column. This column here, x bar 2 3 4 5 6 7 8, and it has listed the frequency against each value. And look here, the total frequency is 16, which is equals to the total numbers in the sample. This is the frequency distribution of x bar. By using this frequency distribution, what you need to do is you will put this frequency distribution on your answer sheet and you will divide each frequency by the total frequency. It will give you the relative frequency or the probability of each mean. So it is the resulting distribution is called the sampling distribution or the probability distribution of x bar. each value I have provided the formula P of x bar is equal to f over summation f. Individual frequency is divided by the total frequency. 1 divided by 16, 2 divided by 16, similarly 3 divided by 16, 4 divided by 16. And you will also have to prove that the sum of this column is equal to 1, as you know that the total frequency total probability is always equal to 1. So I have done all the procedure for the first case, which is the sampling with replacement. What you people need to do is, you will, for the second case, for the sampling without replacement, you will do all of this procedure by your own, except how to make the samples. I will get you learn here how to make or form the samples when sampling is done without replacement, and rest of the procedure is same as the previous case. You will do it by your own. Okay, in sampling without replacement, how we will form the samples? I have listed all the population again, the same population which I have used in sampling with replacement. The population size is 4, sample size is 2. The only difference with the previous case is that the total number of possible samples. The total number of possible samples in sampling without replacement is find by the formula NCN, that is population size combination sample size. 4C2, 4 combination 2, which is equals to 6. And you can calculate this combination thing on a scientific calculator very easily. So I must have 6 samples here. And I have listed these samples as you know, it is the case of sampling without replacement. So when 2 is selected at first stage or first drawing, you know, it is not returned back into the population. So 2 cannot be selected with 2 again. So 2 can come with 4. 2 can come with 4 only. Similarly, 2, 6 and 2, 8. Now 2 is completely exhausted from the population. It is no more in the population because I have not returned it back into the population before selecting the 4. Now it's a turn of 4. 4 cannot come with 2 and 4 cannot come with 4 as well, because 4 is selected at first stage and 4 cannot be selected at the second stage. So 4 can come with 6 and 4 can come with 8 only. Similarly, 6 can come with 8. 6 cannot come with 4, 6 cannot come with 6. Similarly, 8 cannot come with the previous units because they are not there. So these are the 16 samples which can be drawn when sampling is done without replacement. What you will need to do, you will enter the data for both of the samples, like I have done. Sample 1 data, this column, and for sample 2 data, these values 4, 6, 8, 6, 8, 8, and you will get the mean calculated, and all the rest of the procedure you will make the frequency distribution of x bar and then sampling distribution of x bar by using this frequency distribution, and then you will have to equate this expression. You will prove that mu of x bar is equals to mu.